Hey everyone, I'm Max. Let's learn how to tackle this educator problem, merge sort a linked list. So let's start by talking about the basics of merge sort. So how merge sort basically works is when you're given an input, say these numbers here, 3, 2, 4, 9, 1, you basically take the input, split it into two equal length halves. So here, again, it's 3 and 2, so I can make 2 and 3 or 3 and 2. So here, like the group of 3 and 2 and the group of 4, 9, 1. And then I run merge sort on each of those halves. So for instance, this 3 and 2 will now just be split up into a single 3 and a single 2, and then merged back up. So again, let's go down the recursive chain. Here, we split the original array of 5 elements into an array of 2 and 3. So that array of 2, that 3, 2, was then split in half again into two arrays of 1 element. So 3 and then 2. And then when you have just one element, you're already sorted, right? So at that point, you return, you stop splitting. And then, so the element or the array with just 3 in it is sorted, and the array with just 2 in it is sorted. So now we come back up to the array of size 2, and we merge the two half arrays together. So here, we would basically look, we have a 3 and we have a 2. Which one is less? Well, the 2 is less. So we put that one in front, and we put the 3 at the end. So we'll have 2, 3 here. And so basically, we'll come back up to the call of 5. And what that is doing, so again, we split the array in half into a group of 2 and a group of 3. And then we essentially called the procedure recursively on each of the halves, which this is a sorting method. So both halves would end up sorted, right? And then we would have, 2, 3 from one half and 1, 4, 9. And again, we run the merge after we've run merge sort on both halves. So here, it would look at 2 and 1, right? And it would say, okay, 1 is less. So I put 1 to the output. Let's see, 2 and 4. So 2 is less. I put 2 to the output. 3 and 4, 3 is less. I put 3 to the output. 4 to the output, 9 to the output. We'll get more into that when we actually start the coding. But you can see that that's actually given us the output we desire. Now, one small kind of wrench in this problem is the fact that we are performing merge sort on a linked list. So normally what you can do with an array is you can easily get the size, half the size, and so then you know the indexes of the like first half and second half of the array. And so when you call merge sort recursively, you can just be like, all right, just work on this section of the array. The other call, work on this section of the array. Like you can pass in that start and end index. That's not something we can do here because we're just working with a linked list, which linked lists kind of have that starting index in the fact that they have a head, but you don't have that ending index. So it's kind of harder to tell the code how many elements they're working with and what range they should operate on. And obviously, there's a few things we can do to counteract this. So fundamentally speaking, instead of taking the size of the array and dividing by half, that's a good way to go, but it's not quite as easy with a linked list. What we can do instead with a linked list is, let's take the size of the total array, right? We know it's 5. We don't get it passed in here, but we can calculate it ourselves as well. So we know this is 5. So in this case, we would know that if we head forward, twice, we would end up from the head, right? Head forward twice to this 4. We would end up in a position where everything before us was one half of the array and everything after us was another half of the array. Or of the linked list, sorry. So if we were to clear this connection here between the 2 and the 4, we just have two separate linked lists, right? And so at that point, we can just kind of pass in this head at this pointing to this 4 and this head at this 3 to our original function. And at that point, again, this is a sorting algorithm. So that's recursively sorting those sub-linked lists. And once that finishes, we'll have the same thing we saw with the array, right? 2 pointing to 3, and then 1 pointing to 4, pointing to 9. And at that point, we'll just have to do a linked list merge, which fundamentally is pretty similar to a array merge. We can just implement it a little bit differently, dare I say, more concisely. But obviously that's many ways to do that, and we'll get to that later. So for now, I want to explore the idea of splitting the input, right? So let's start coding. So this sort list, we're just given a head. Now, again, to perform merge sort, we really need to know the length of the array normally. Here we're given a linked list, so we need to know the length of the linked list. Now, how would I normally do length of a linked list? Well, I would just iterate through. Problem is, what if head is, null? There's like no elements in the linked list. That could potentially cause some issues if we try and go forward at a null pointer. So what we can do instead, or what we want to do, the question does not tell us that head can be null or head is one element or really the bounds of our linked list. So just to be safe, what we'll do is we will include some code here. So if there's no head, if head is a null pointer, or if there's no head next value, what that means is that there's only one value, the head, in the linked list. In that case, we know it's sorted. So we can just go ahead and return the head in this case, right? So that's our kind of edge case where there's 0 or 1 element and it's already sorted. Now, at this point, we know there is at least 1 element. In fact, we know there's at least 2. But we'll have a length variable. We'll start it at 1. And at this point, what we can do is we can create a little scout node that will initialize the head and will send through the list to find the length of the list. So how we can do this, let me adjust this indentation. Here we go. How we can do this is we can just say like, while scout has a next element, we can increment the size and set it to the next element, right? So length will start at 1, but you can imagine if the length is, say, 2, right? The scout will start here. It'll see that it has a next. So it'll head over to 2. It will increment the length to 2. And then here we'll see it does not have a length. So length stays at 2 permanently. And that's how we can get the length of the linked list. So now we have the length. And this allows us to make more informed decisions with how we want to actually split our linked list. And so just for, to write a bit conciser code, I'm going to make a helper function for this. Because again, merge sort is a recursive algorithm. So let's implement something recursively so we don't have to keep finding the length every time. I'll call this split and merge, maybe. And we'll pass in the head and we'll pass in the length. So if we, and we'll probably have it return the node because it's recursive. Split and merge node head, and this is also passed in a int length. Now, what does this want to do? Well, the first thing, again, when we're doing merge sort, is we want to take this linked list full of values and split it into 2 linked lists of values. So what we can start by doing is we know the length of the entire linked list. It should be fairly easy to calculate how far we have to go until we get to the second part of that linked list, right? The head that points to the second half, rather than the head that points to the entire linked list. So how we can do that is we can just make a node, or actually, before I do that, you know what? I'll get to that later. So we will, we can make a node. Let's just, it's pretty straightforward. Let's call this second head. We'll set it equal to head. This one will advance to where the kind of middle node is. So let's think about how many times we would have to do this, right? So it doesn't matter if we are, like, sometimes it's uneven, right? So it doesn't matter if the second head starts here or if it starts here, right? But one thing we do want to account for is the odd case, right? So say there's only 4 nodes, right? We want to make sure this code will always work. So if we just did, I think the easiest thing is just length over 2. X is less than length over 2. What would happen here? So length here would be 5. Head would start here, and it would iterate 2 times. X equals 0 and x equals 1, because length over 2 would be 2 when when length is 5. So it would iterate 1, so it would go once forward to 2, and the other time forward to 4. So it would give us this half of the array. That looks good. What about here? So here length is still 4, or it's still 5, or sorry, length is 4, but length over 2 is still 2. So we're still iterating twice. We'd iterate once forward to 4, and then, or once forward to 2, and then again to 4. So again, this does give us half of the array, right? So this actually looks pretty good to me. What we'll do here is pretty simple. We'll just go second head equals second head next. And again, we're doing this enough times so that we eventually get to that second half of the array. Now, one thing that we can do here that kind of makes our life easier is this is a linked list, right? And again, we want to kind of like distinguish our two halves pretty clearly so that later when we're merging, we don't run into complications. So if we could somehow just take the two halves, so right before the second head is, or right before where the second head is, and literally like split them like so, then it kind of makes conceptualizing the problem as well as coding it a whole lot easier, because then you literally have two other sub lists that you can just recursively work on. And notice that right now we have the second head. So it's kind of hard to work backwards, right? Sever the connection that goes into the second head. So what we can do instead, we'll subtract 1 from here. This will give us the node that comes before the second head, right? The 2 in both of these cases. And then we can like store a temporary node. So like here, second head next. And and then here we can go like take the second head, which, you know what, I'm gonna make this a little bit more readable, in some ways of speaking. Before second head, right? We know that this is the 2, so this is before the second head, and we can set this, just call this second head, which is the actual next one, and then we'll say before second head next is null pointer. There we go. So again, what this has done, we've iterated. First, we found how to iterate to the second part of the array. We've done one less iteration to get us to the node right before the node that leads to the second part. And then we store that second head, which is just going 1 further forward, and we cut off the connection between those two nodes with this. So at this point, we have 2 separate nodes here, this head and this head, the first head and the second head. At this step in merge sort, you've split into 2 halves. Now you want to recursively sort each of those halves. What we could do is we could just pass in the heads like this to sort list. Everything would work. What's a tiny bit smarter is instead of having to recalculate the length of these halves, we already know their lengths, so we can just directly call split and merge, right? So we can go head is equal to split and merge head. And here we can pass in the length. Now we know that this first half is always going to be the size rounded down, right? So we'll do length divided by 2 like so. And then we'll go second head equals split and merge second head. And here we want the length rounded up, or the length halved but rounded up. And we can do that with this expression here, just adding 1 to the length before we have it. And again, that just saves us passing these in because we know we're having the array in a certain way, just saves us from having to recompute the size of each of those. You could call sort list on just the heads, that would work as well. But again, this makes things just a little bit faster for us. All right, so at this point, all we need to do is a merge function on the two halves we have, right? So we've split the array in halves, and this, again, we're writing a function that will split and merge. So we're going to assume that these two have already been, split and then merged. So we'll have them sorted like so. At this point, we need to write a function that will merge the two. So we'll just go like merge head, second head, and then return that head. In fact, we can even just say return the result of merging the two, right? Because if we can merge these two into a full array, man, I'm stuck at counting, 4, 9, then we have our output, right? So again, we've done the splits. We've recursively called merge sort, which would make each of the halves sorted. And now we just need a function to actually merge the two together, which means that like if this was 3 and this was 4, it would still return something like this, right? That's ultimately what we want to do with our merge function. So let's write our merge function. And take a quick drink first. This is a pretty long problem. Been doing a lot of talking. Sure, I'll do some more. Merge. So we'll have one node A, and then a node B. So let's talk about the merge function. So normally, when you do a merge of arrays, right? What you essentially do is you have a pointer to, or an index of where you are in each array, right? So here you could store like, a pointer. I'm at index 0 in array A and index 0 in array B. And then you take the smaller element from each of the pointers and increment that pointer. So here you would take 2 and add it to the final list and then increment that pointer. And just keep doing that. So here you could take 3 because it's smaller, add it to the final list, increment that pointer. Here you would take 4 because it's smaller than 9 and put it to the final list. Here you can't increment that pointer. So at this point, you would just take everything from the second list directly into your output. And with linked lists, it's a little bit different because instead of iterating indices, we are literally going to be iterating the position of our node pointers here, right? But it does also kind of, I think, make realizing the merge as a recursive function a little easier, which is something that we don't always talk about, but I think it does make the code a little bit shorter, so I like that. So let's talk about merge as a recursive function. If we have 2 inputs, what's our base case, right? When will we know what to return? Well, if A is a null pointer, right? We would just return B because that's like running out of elements in one array and just having a bunch of elements in the other that we just essentially need to paste into the output at this point. That's what this is doing, right? If we have no elements left to take from A, we can just return B in its entirety as a list and append that onto whatever else we were doing. Similarly, if there's no elements left in B, if B is a null pointer, we can just return A, and that's the merging of that null pointer and all of the stuff in A. Here it gets a little bit more tricky. What we'll do is we need something to return. So let's make a node called like result. Let's just set it to null pointer for now. When we do this recursively, right? All we need to do is take one smallest element, set res to be that element, and then move A forward, and then have res point to the result of like the recursive call when A is moved forward. Let me just write some code and hopefully it'll kind of make sense. So we got to check the values, right? Merge, obviously we want the lesser values first. So we'll go if A value is less than B value. So at this point, uh, we're given two lists, and we know which are sorted, and we know the first index of one of the lists is smaller than the other. Obviously, that value has to come first overall, right? And so what we'll do here is we'll set res equal to A, essentially saying res is our first element in whatever we're returning. So we'll set that to A. And then we'll set the next value in our output after that A, that smallest value, to be equal to merge of A next B. If this doesn't make sense, you can kind of think about this in terms of how we merge sort with an array, right? This is sort of like taking one value and writing it to our output. This is sort of like then moving our pointer forward one, right? Because we're essentially taking one value from one of the linked lists and moving our index or pointer forward in that linked list for the rest of the merge. Here, when we do the rest of the merge, we can just do it recursively like so. So again, all this code is doing, given two linked lists, sorted linked lists, obviously the smallest value overall has to be the first element of either of the lists, right? So it just compares the first element, it takes the smallest of those two, and then it takes the other list and the rest of that smaller list with that first item removed, and just merges those, and then combines the first smallest element it found with the rest merged together and returns that. All right, hopefully that's starting to make sense. Here in this case, the B value would be smaller. So we'll do res equals B, and then res next equals merge A B dot next. Because again, we're taking that value from the B list and then incrementing that B index or pointer. Here, we just return res. It's this easy. A lot of times the recursive code will just be shorter because you're kind of compacting a lot of logic inside of one, I don't know, recursive statement here. So again, this merge, we know what the merge does overall. What the recursive implementation does is it takes the smallest value, attaches it to like whatever it's returning, and then just says, okay, we'll get rid of that value, merge the rest of the other two lists, and then we'll just attach the smallest value we found to the front, and it'll be merged in entirety. So this, in the split and sort, or split and merge, we will split or merge the two sublists together to give us that sorted array in its entirety, which is then returned. Let's see if this works. Error. Okay, it looks like I use a dot instead of an arrow somewhere, probably in the merge. Here it is. Exited with status 137. Compilation error somewhere. This is not a very descriptive error here. I may need to splice the recording until I find the issue. Oh, of course. So we never, okay, yeah. This is what I said I wanted to get back to, and I never got back to. So right now the split and merge, it just keeps splitting the array in half, in half, in half, in half, in half. At a certain point, we know that the halves are already sorted, right? We don't have to go through all of this garbage, right? If we're ever past a head, which only has a length of 1, we can just return the head. That's our base case to our recursive function. Just like this is the base case to this recursive merge function, we need a base case for the split and merge. I just forgot to implement it. And in this case, it's just if a length is 1, because in that case, we don't have to split and merge. We already know it's sorted. Let's see. Hopefully that's fixed it. Jesus Christ, what's happened to the values here? I don't know how I could have messed that one up. Probably because I've screwed The input up. Okay, yeah, that got me really confused. Um, but if I submit here, yeah, there we go. It's passed. Someone came and told me to turn the lights on too. Goodness. All right. But yeah, hopefully that's cleared that up. If you have any questions, feel free to contact the TAs on Slack. Um, and yeah, good luck with your other problems.